help you determine the orientation of the what? Vector surface. Okay. Now, you will say, Eugene, this is just one for me and so. Let's do in shear now. Okay. So we're going to do this in shear. So those of you who have chalk, be ready. Don't panic, but be ready. So what we are going to do is we are going to induce fracture in this orientation, or we're going to load the structure in this orientation. Okay. So what this means, your left hand, so if I were to draw this, okay, your left hand fix. We're not doing buckling, yeah? No buckling, okay? Your left hand fix. Your right hand, you're going to push, you're going to rotate away from you. When I say rotate, you have to be very precise. Okay? Don't do anything yet. You have to be very precise. You cannot rotate and bend. If you rotate and bend, we are in a big doodle. We can only what? Rotate. Because if you rotate and bend, what happens? You are inducing bidirectional loading system, which undergrad courses we don't really handle. We're going to just generate uniaxial direction or unidirection. Okay. So now, you don't do anything, okay? Just watch, okay? This is not a cooking show. This is real shit, okay? Cooking, I like cooking show, okay? Cooking show. This is my element now. I'm going to induce a shear. I will label this as my surface X and my surface what? Y. Can you see that? Okay. Then those of you who are having the chalk, don't do anything first. This is fixed. Okay. And then this will what? This will rotate. Remember, in a shaft analysis, when the shaft is rotating, is it under any stress? No. Stress only occurs when one side is fixed, the other side wants to what? Move. That's why do not engage your car moving forward, go into reverse immediately. Are we clear? If it's rotating, if okay, so watch. Okay. So I'm going to twist. I will twist down here. Okay, I'm going to twist. So this angle, what angle is this? Defining. So those of you who are having the chalk, I want you to do the same thing. Left hand hold, right hand what? Okay. Okay, don't bend, don't panic. If it does not work, it's fine. Do you all see the 45 degrees? Yes or no? You all do see the 45? Yes. If you don't see the 45, probably you're bending it. It's okay. Okay, so now, I know this has been shown in 2P. We go a step further. How we are going further is we are going to look at what? Mole circle. Okay? We're going to look at mole circle. So on mole circle, what we have this is normal stress, this is shearing stress, element will rotate clockwise, element will rotate anti-clockwise. This is our point X, and this is our point what? Y. Okay. And over here, like what we drawn earlier, if you put your finger at the center, the shear stress will generate a clockwise rotation. Clockwise rotation will be point X, and anti-clockwise direction at point Y. Sorry, this is going anti-clockwise, and Y is going clockwise. So we draw a circle. Okay. Can you still see? Over here is what? Tensile. Over here is what? Compression. If you look at point X, rotating in an anti-clockwise direction, this is what? How many degrees? 90 degrees. Yes or no? Okay, now wait. Okay, that is 90 degrees. So if we were to draw, now 90 degrees clockwise or anti-clockwise? Anti-clockwise. Right? 90 degrees anti-clockwise. So can you see my chalk now? If I put my chalk over here, it rotates clockwise or anti-clockwise? If I take my chalk here, if I draw a vertical line, which is my X surface, is it rotating clockwise or anti-clockwise? Anti-clockwise. Yes or no? To the fracture plane. Okay? It will rotate anti-clockwise to the what? To the fracture plane. Okay? Now, some of you say Eugene. Wait, before I say some of you might say Eugene. We realize that when we do tension tests, stupid pen dying. Cheap Japanese pen. Right? When we stretch, right, this surface what? Fracture, yes or no? Just to recall, yes or no? Now, when we do 45, it fracture at this orientation. Anti-clockwise by what? 45. Why? Because most circles say it will rotate anti-clockwise by what? 90 degrees. Okay. Now, in the real world, this is the real world where you see you and me. In the real world where we have element that from point X to point Y is how many degrees? How many degrees? Come on, 90 degrees, yes or no? On most circle, point X to point Y is how many degrees? 180. So if in most circle, freaking pen dying. Gentle, Eugene, gentle. They are kids, don't be rude. If on most circle is 90 degrees, on the element, which is the real world, it is how many degrees? 45 degrees. So that is why we can predict the direction of the what? Of the fracture. Now, some of you say, Eugene, why didn't we rotate this direction? Evans, why didn't we rotate in this direction and we will still reach this point? Okay? Okay. Let's help Evans out. When we start the demonstration, what direction did I tell you the chalk will fail in? Under what loading condition is it for me to easily break the chalk? Which direction? Tension, there you go. So over here, this is the yield strength, okay, for tension. The yield strength for compression is over here. You know what I mean? The yield strength in compression. So the chalk did not fail in what? Chalk failed in what? Okay. Now, this is a hypothesis. as engineers, you need to do what? Hypothesis. Right? Now, how do you know that this is right? What is right? That chalk will fail in tangent. What will happen if now we were to reverse the direction of the shear? What will happen? Okay, so now let's focus on Mohs circle. Okay, let's focus. What will happen if we reverse the direction in shear? Okay, now listen. Mechanical engineers, we have to be able to relate. Are we clear? That is why when I teach you bending moment, shear stress, or whatever forces that I'm teaching you, did I look at the textbook? Textbook is out of the way. Okay, but all these concepts were derived from the what? From the textbook, not from the chalk. Okay, now watch this. Okay, so now we are going to use Mohs circle to predict the orientation of the what? Of the fraction. Okay, so what we are, so the other chalk, don't do anything with the other chalk. Okay, the other chalk, don't do anything. The chalk, cheeky sort. So the next one we're going to do is we are going to do with opposite direction. Okay, now this is the what? This is the opposite direction. So what are we going to do different down here? So this is our chalk. This is our what? Our element. Your left hand, you're going to what? Fix. Your right hand, right hand, you are going to move towards you, rotate towards you. Okay. So when this is the case, the shear direction changes. So if this is my point X, this is my point Y. Now I sketch Mohs circle. This is my normal stress, shear stress element, rotate clockwise, element rotate anti-clockwise. So point X now will be up here. And point Y will be what? Down here. Then we start drawing our circle. And we know fracture will occur here. And this means this is 90 degrees. But what is that 90 degrees mean? Okay. So now if we have this now, right? Our fracture, so this is our X and this is our Y. This has to rotate what? 45 degrees. It has to rotate 45 degrees. So the fracture will be in this direction because if I were to draw this, rotate 45 degrees clockwise, okay, you translate over across, this is also 45 degrees. Okay. So is this true? Okay. So now the other chalk. We have a lot of chalk at McMaster. You guys pay $1,000 for the course. We have a lot of chalk. So now this is our element. This is how we are going to fracture our chalk. And this end is fixed. And this hand, we're going to rotate towards you. Okay. So when I do this, right, you look at the fracture surface now. Okay. The fracture surface now is exactly the same as how I draw this line. Okay. So from point X, so this is our surface X. It will rotate what? Clockwise by how many degrees? 45 degrees. Are we clear? Okay. So this is the first test that we have done. Okay, so this is the first test we have done. Hey, come on, Eugene. I think I've been taking too much drugs to calm myself down. I'm always shaking. And this is the other direction. Can you see that? Yes or no? Right? Can you see the difference? Yes or no? Okay, so by using what? By using Mohs circle, okay, we now can determine the what? The direction of the fraction. Again, when we do Mohs circle, right, we look at the right-hand side because the yield or the fracture of chalk in tension is less than what? Compression. Are we clear? Hey, this is what engineering is all about. Whatever you do, if you cannot do experimentation, you have to rely on two things. What are they? Three things. If you cannot do experimentation, you have to rely on two things. What are the three things? Number one is what? I'll give you the hint. Math. Number two, common sense. Fist bump. Number three, no, physics. The physics has to work, then you're okay. Be clear. That's why mathematicians are